We look into mirrors every day. They show us our reflection, help us get ready, and even make rooms look bigger. But have you ever thought about how mirrors actually work? Mirrors are simple yet fascinating pieces of technology that rely on the science of light and reflection. So let's dive into the logic behind how mirrors work. A basic mirror is typically made of a sheet of glass with a thin reflective coating applied to one side, usually silver or aluminum. When light hits the reflective surface, it bounces back, creating an image, but there's a lot more science involved here. The glass serves as a smooth surface, protecting the reflective layer and making sure that the light reflects evenly to create a clear image. The way mirrors work comes down to how light behaves. When light rays hit a surface, they either pass through, get absorbed, or reflect back. In the case of mirrors, light reflects almost entirely back thanks to the smooth metallic coating. Mirrors follow a basic rule of physics called the law of reflection. This law states that the angle at which light hits the mirror, known as the angle of incidence, is the same angle at which it reflects off, called the angle of reflection. Because mirrors have an incredibly smooth surface, light reflects in a uniform direction, allowing a clear image to form. On rough surfaces, light scatters, so we don't get a reflection. You might have noticed that mirrors seem to flip images horizontally. If you raise your right hand, your reflection raises its left hand, so why do mirrors flip left and right, but not up and down? Technically, mirrors don't actually flip anything. Instead, they create what's called a front-to-back reversal, meaning the image is reversed along the axis perpendicular to the mirror. The mirror reverses the image depth-wise. What's closest to the mirror stays close, and what's far away stays far. This is why it looks like it flips horizontally, even though it's actually just flipping the image along a different axis. Not all mirrors reflect images the same way. The shape of the mirror can change how light behaves and the type of images it creates. Flat mirrors are the most common and show a true-to-life reflection, where objects appear at the same size and distance. Concave mirrors, like those in some makeup mirrors, are curved inward. They focus light to a point, which can make objects appear larger when held close to the mirror. On the other hand, convex mirrors curve outward and spread light outwards. This creates a smaller, wider field of view, which is why they're used in places like car side mirrors to give a broad view of what's behind you. That's why you'll see the warning on side mirrors, "Objects in mirror are closer than they appear." Mirrors aren't just for checking your appearance, they're used in everything from telescopes to cameras to laser technology because of how precisely they reflect light. In telescopes, mirrors gather and focus light from distant objects, allowing us to see stars and galaxies millions of light years away. In lasers, mirrors help direct and amplify light, allowing for precise cutting in industries and even in surgeries. Mirrors are also used in art and architecture. They can make spaces feel larger and add aesthetic appeal, playing with light and space. So, the next time you look in a mirror, remember that there's more than just a reflection. It's a perfect example of how science and light come together in everyday objects. From the simple law of reflection to complex uses in technology, mirrors are a fascinating part of our daily lives. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and check out our other videos on the science behind everyday things.